So basically today we are going to live stream a bit about QGIS. I'm going to practice it from the very basics. Thus, I'm creating this live stream and I'm really excited to practice the entire concept. So the particular syllabus that I have for this upcoming examination is, wait a sec. The upcoming syllabus for this examination is, I'll just try to link it to the entire image to I have to add another image. So this is going to be the syllabus for my upcoming examination. Okay, I have to reduce it a bit. Yeah, so even if you don't see that, that's fine. Yeah, so this is basically the syllabus for this upcoming examination. Okay, initially we are going to start with the GIS portion where we are going to understand the digitization of features and administrative boundaries, data attachment, overlay, and preparation of annotated thematic maps. And after that, maybe we can focus on the supervised classification of image. First of all, I just want to remind that I've completely forgotten the entire GIS module, and it is a bit difficult for me to understand that. Not exactly difficult, I would say, but something that I haven't done for a while now. Okay, so initially we are going to import a particular map that will help us to identify that what exactly we are working with. Okay, then first let's open a map. Let's go to QGIS, and then um, we have to add a layer. We have to add a raster layer, and then we are going to add the Hoogly map. Okay, as we add the Hoogly map, okay, we can observe that there are some latitudes and longitudes, but this map does not have any kind of georeferencing. So initially, what do we have to do? As you can see, these coordinates are wrong, right? So we have to go to particular place, which is the raster portion, and then go to georeferencer, and then import the same map that we had before, which is the Hoogly map. Okay, after we import this, we have to add a few ground control points, which are also called the GCP points, that will help our computer to identify what exactly we are dealing with. And for this point, the particular lat long is 87 degree 30 minute, 87 degree 30 minute, and then we have the 2300, and try to make sure that you go in either clockwise or an anti-clockwise direction so that you get the maximum accuracy, or else the computer might get confused a bit and that might create a problem for you people. Okay, then the next one is this one. For ground control points you need minimum, I mean minimum is like 4, and maximum you can go as much as you want to, because the more points you have, the more data the computer has to process where the map is exactly located, which enables it to easily process things. So it is very important that we actually do this. So after we gave some of the GCP points, our work is to give it a transformation. So in this, we are using polynomial 1 and then resampling method as this. And then we are going to use the 45N. Okay, we're going to be using the UTM zone 8445N. Okay, because we are basically dealing with the certain. And now we have to add this. So that, why am I getting a huge error? Maybe we can try moving the GCP point a bit, but this shouldn't be this bad. I mean, why is my GCP coming to be there? I don't think this is correct. Something is pretty wrong with the map, with my georeferencing. I think the mirror is pretty normal now. But the question is, this is what I was facing. See, there is no fourth point. There are three GCP points. Two, three, and four. Let's see. Let's see if it is georeferenced properly or not. Once we import it, and we will see there are two GCP points at the same place. Maybe I ended up writing something wrong. Okay, okay. Let's try removing every single one of them. Okay, let us redo the entire GCP thing. Okay, we're going to again add some ground control points because we have 8730 and then we have 2300. Okay, first one is done. Then we have 8830, and then another one is 2300. So yeah, things are good till now. 2300, and then we have 880030. Oh, here I made a mistake. I made a mistake here. This would be 2230. This one would be 8830, right? Yeah, I made a mistake again. First would be 8830, then would be 30. Yeah. We have our correct. See, yeah, the mean resolution is working pretty good now. We can fix the error a bit. So we have to select move this. I'll opt for lesser than 1. That's all I need. Yeah, I think this is good. Okay, so now the mean error has been done, and save GCP points. And we are going to create a new input, like new raster, Hoogly JPEG GCP. Okay, now once we are done, we will import the new file. How did we do this? I think I messed up with the file format. This one was the file. Okay, now we got our coordinates. And how do we convert into meters? Go to this one. This one will also be Yes, now we have our coordinates proper. See, 88 and 22. So now that we have arranged this one, our next task would be to convert it into a from a raster. We'll convert it into vector shape files, which is very important for the development of how we are actually trying to structure it. Okay, so let's start. We have to vectorize everything from the district blocks to arrangement of the railway, and I think this is the roadway. Yeah. So we have to digitize everything, and let's see if I have any resources for um, I think this would be a better option if I do the map of Bakuda, because then I'll have some data to copy. Do I have Goghat 1 and Goghat 2? Do we have that? Yes. So this map has all the. Okay, let's do something. First, let's digitize the entire map, and then we'll enter the male and the female population. We'll also find out the area and the density of the population from this part. Okay, so our task would be to add a new layer, which would be a new raster layer, I mean a new vector layer. This name would be CD blocks, which we can't save here. We have to save it in the file itself. Okay, it would be a polygon data, and then the projection would be 45N. The name would be CD block. Okay, that would be a text data length. I think 20 would be enough. Then add the field list string. Then we should also add a data table for. No, we'll do it once we create the male and female population. I think that would be better. Then we'll also get to practice it. I have to click on this pen and this one, and then we have to digitize the entire thing. See, I'm not doing it like 100% accurately because this is for practice. And if I try to maintain 100% accuracy while I'm trying to digitize it, I'll lose a lot of time. Oops. We messed up, guys. We messed up. The name of the CD block is Rogat 2. Now something that we have to do is we have to enable our snapping. Okay, snapping, advanced options. We have to choose our layer, avoid overlap, snapping at intersection, topological editing, and we are done. So now what we can do is we can start here. You have to ensure that you do not miss out on this portion. I think I named both of them the same thing. Check the attribute table for once. Yep, number one should be one. We can change that later. I think we'll work with just 6 CD blocks rather than converting the entire thing into vector. I think we'll keep it till Coursera. Okay, now we'll turn off this map. We don't need it anymore. And we'll enable labels. Okay, we got go-kart 1. Oh, yeah, this is save edit, turn off editing, and we have to rename this. Yes, save. Okay, so now that we are done with this portion, we are done with taking a few CD blocks. Now next task would be to input some data. I think I should remove the syllabus now. Yeah. Yeah. Now the syllabus has been removed. Now our task would be to add some data. First, we are going to make a few bar, then a pie chart, and then population density. Okay. For that, we need a few information. First of all, we have to open attribute table. Then we have to enable editing. As we enable editing, there would be option for a new field. New field, yes. Name of the field would be male. Whole number, integer. Yes. Length maybe 15. Okay, male of Bogart 1. 56506. Male of Gogart 2 would be 63399. Male of Arambagh would be 115249. Male of Kanakul 1 would be 100743. Male of Kanakul 2 would be 76060. And then Pursurat would be 73270. And then we're going to make a new field called female. This is also going to be a whole number. Okay, number of females in Gogart 1 is 53040. Six zero two three five. Then we have 107393. Then we have 21647. Then we have 95564. And lastly, we have, wait a second. No, 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 we don't have this one. We have 95564 as you. Then we have 74419. And lastly, we have 68637. So I think, if I'm not mistaken, Acha, okay. I think I also have to make another for buffalo, cow, and things like that. Kusura, Kogart, yeah. I mean, this is. I think I made a good choice on choosing these five places because they are very much adjacent and it's good. Cattle, yeah. So in the cattle we have first Gogart one as 69964. Then we have 79199. Then we have 63814. Then we have 52588. Then we have 89348. And lastly, we have 39329. We're going to make a new field called Buffalo. Buffalo in Gogart 1 is 69964. In Gogart 2, we have, no, wait a second. This is for cattle. Buffalo in Gogart 1 is 84. My God. In 2, we have 987. In Arambagh, we have 2056. In the next one, which is Kanakul 1, which is 61. The next one is 0. The next one we have what? 1521. No, yeah, 910. Then the next field is goat. In goat category, we have Gogart 1, 34563. The next one we have 37967. Next one we have Kanakul 1, which is 43878. The next one we have 21546. Last one we have in Pursura we have 27980. And in Arambagh we have 46311. The next category that we have is poultry. Okay, so in poultry we have initially as Gogart 1 of 39011. Next we have 71826. Next we have 74181. Next we have 50376. Okay, now let us try creating a bar graph, a symbology diagram. We'll create what are we creating? We're creating diagram pie chart. Attribute female, male, Okay, so here we are with all the male to female ratio of Hoogly map. Mm, we can create a print layout of this. P1. Is the male and the female population added equals to the population, correct? Oh, the attribute table couldn't be seen the entire time? But yeah, the last thing we are left with is calculation with the area, and I have to just check the area. Where is the area value? Hmm, total. Where is the area? Okay, if we do not have the area data, we can arbitrarily create an area data. Let's create a new field call it area. So let's assume the first one is 250.661. Oh, okay. I can't enter 3500 and then 650. Then we have 420. Then we have 275, and the last one would be $300. So let's assume we have actually calculated. Oh, area does not need to be created. I remember now. Area. I think we were using the math called percentage area. Area. Yeah, this one. Okay. No, there was some calculation. How to calculate the area of vector in QGIS in field calculator. Right click on the layer, open attribute, toggle editing, find field calculator. For kilometers, type this. Okay. Divided by 1, 2, 3, 4, 5, 6. 6 zeros. Okay, we'll see. So the area, and then number two decimal numbers. We'll keep it to 12, and then we'll add area divided by 1,000,000,000. Still didn't get the area. Why did we not get the area? Must be somewhere that I'm doing a mistake. If you open the field calculator, click new field called area, we'll put for decimals, calculate area. They're not getting the area. My area is coming as 0. My area is coming as 0. What if I do ABS area? ABS. Yeah, but we forgot to add the First we have to go to vector, then maybe to geometry tools. Fix. Check validity. Mhm. Um, okay, I have to learn this part. Thank you for watching this.